Okay, so I'm going to do a quick little video about deriving this equation here. So this is the equation for surface gravity. Okay, so we're going to go through it and it'll be using most of the things we basically know. So if you remember surface gravity, that's your planet. In this case it's going to be the Earth, because that's what our little g is. This is surface gravity for Earth. The acceleration for surface gravity. And this is going to be your distance. Okay, and this will be the little person up here. Okay, whoop, barely see that, can you? There we go. Okay, so there you are on the top. And basically all this big or is just going to be the radius of the Earth. It's how far we are from the center of mass. Alright, now to get this, so they can ask you a few things to derive the surface gravity or the acceleration due to gravity on the surface of the Earth. And this is actually quite easy. We just need to remember a few of the basics. So first we have to remember what weight is. Weight is a force, isn't it? Yeah, weight is a force, and we remember that. And a force is equal to the mass multiplied by the acceleration. But specifically, when we say weight, we're talking about the acceleration due to gravity at the surface of the Earth. So again, we're just going to have mass, but instead of this acceleration, we know our acceleration is the acceleration due to gravity. So we know our force, this is our weight, and it's equal to mg. Now, we're dealing with gravity, so of course we already have the other equation that you're going to find in your book, okay, or in your log table. So it's going to be F is equal to g m, or sometimes that's written m1 and m2, all over r squared. Okay, so this is just written in your log tables. You don't have to remember this. And these are your two masses, because the force of gravity has to be between two things that are going towards each other. That's the force. G is just your gravitational constant. Again, that's going to be in your log tables. And r is just the distance from the center of a mass squared. So we basically nearly have it done here already. So this is your weight, which is a force. So we know that mg has to be equal to this because it's already a force. So we're just going to put them beside each other. Mg is equal to, because the weight is equal to the force. So mg is equal to g big M little m over r squared. Yeah, so that's all it is. So once we've made this, and then we can just look and we can cancel out things straight away. Now, you might, usually in these, the big M stands for the bigger mass, but really it doesn't make much of a difference. So we can just get rid of this M and cancel any one of those M's, and it doesn't really matter. And already you can see now we can do G is just equal to big G M over r squared. And this will work for any planet. Okay, so this will be the surface gravity, or the acceleration due to gravity at every planet, at any planet, is going to be the mass of that planet. This is the gravitational constant, which never changes, and this is going to be the radius of the planet. Okay.